Hello students, hi everyone. This is our second video of the topic reflection of light at curved surfaces. As already we discussed something about the reflection of light in our first video. Those who not watched the video, I suggest you to first go through that video. There we discussed about how the light starts from a self-illuminating body and how does it strikes a surface, and after striking how does it reflect back. And also we discussed the law of reflection. What is the law of reflection? The law of reflection is angle of incidence is equal to angle of reflection, means I is equal to R. It means if you take a particular surface, for example this is a plane surface, on this plane surface if a light ray incident, the light ray which is coming from an object or from a source of light and which strikes the wall is known as incident light ray. This is the incident light ray. Okay, and after striking the surface, what happens? Again it comes back onto the same side of the surface. Okay, so this light ray which returns back from the surface is known as reflected light ray. This is known as reflected light ray. Understand? The light ray which strikes the surface, which comes from a source of light. Suppose it is a source of light. From this source of light, many light rays will come, isn't it? But we are selecting a particular light ray towards this surface, and this light ray comes and it strikes the surface. It means it incidents on the surface. That light ray which incident over the surface is called incident light ray. And after that, it again moves back onto the same side of the surface. This light ray is known as reflected light ray. Now, what is the law of reflection? There are 2 points. The first point of the law of reflection is the most important one. Here that is about the angle of incidence and angle of reflection. Isn't it? So, already we discussed how to measure the angle of reflection and angle of incidence. To measure the angle of incidence and angle of reflection, we have to take a normal mean a perpendicular line to the surface on which light incident. Okay, so from where we have to take that normal line? From the same point where the light incident, at the point, this point is called point of incidence. So at this point we should draw a perpendicular line to the surface. So this perpendicular line is known as a normal line. Normal in the sense a perpendicular to surface, a perpendicular line. Normal in the sense it is a perpendicular line. So first of all we should draw a normal line, a perpendicular line to the surface. So after this, now we have to measure the angle between incident light ray and the normal. This angle, the angle between the incident light ray and the normal to the surface, this angle is known as angle of incidence because it is the angle between the incident ray and the normal. And the same way we should measure the angle between the reflected light ray and the same normal. It means we are measuring the light rays, we are measuring the angles with reference to the normal, isn't it? This is the angle of reflection. In this way we have to measure the angle of incidence and angle of reflection. Now what is the law of reflection? The law of reflection is that these two angles must be same. I is equal to R. Mean the angle of incidence must be equal to angle of reflection. So this is the most important point in the discussion of the reflection of light. So whatever the type of surface may be, here we have taken a plane surface. If you take a curved surface, for curved surface also we have to draw the normal. With reference to that normal, we have to measure what is the angle of incidence and what is the angle of reflection. Now let's see how to draw the normal, a normal to a curved surface. Okay, let's see now. Drawing a normal. Drawing normal to a curved surface. To a curved surface. See, so there are two types of curved surfaces basically, concave surface and convex surface. Later we shall discuss about them. First let us discuss how to draw the normal to a curved surface. For example, this is a curved surface. Understand? This is a curved surface. At this particular point, if you want to draw a normal, how to draw that normal? First of all, we have to draw a tangent line, a tangent to that surface. We know about the tangent. This is called tangent, a tangent. The tangent is nothing but a line which touches the curve at a single point. It just goes by touching the surface, that curve. If you draw another line like this line is not just touching, it is intersecting the curve. It is intersecting at two different points. So this is not the tangent. This is not the tangent because it is intersecting at two different points. But the line which just touches a curve at single point, at one point, that particular line is known as a tangent. So this is not going to be a tangent. This is an secant line. Actually, the line which intersects at two different points is a secant line. So now, if you draw a tangent to that particular surface at a point where you want to draw the normal, after drawing this tangent, now you just draw a perpendicular line at the same point to this tangent. Now this is going to be normal. This is the point of incident and the line which we have drawn is a normal. It's a normal. Now if a light ray incident on the surface, this is the incident ray and the angle is I, and it reflects back, and this is the angle R. Again you can say I is equal to R. So whatever the type of surface may be, if it is a plane surface, we can draw very simply the normal, a perpendicular, direct perpendicular to the surface. If it is a curved surface, what we have to do? We have to draw a tangent, and to that tangent we have to draw the normal. This normal becomes what? A perpendicular to the surface at that particular point. At that, because its curvature changes from point to point. So this is not going to be normal at all the points, but at that particular point it is the normal. Understand? If you take, actually we have taken a convex surface. You can also draw the same thing for a concave surface. Okay? Yes. Next, here we shall discuss about different beams of lights. Different beams of light. Beams of light. What is the meaning of a beam of light? A beam of light means a bunch of so many light rays. Actually, if you take a source of light means maybe sun or maybe a bulb, tube light or a candle, whatever that may be, which gives the light, that is called a source of light. So this source of light will give the light rays, it spreads the light rays in all the directions, isn't it? Now, if you take a bunch of light rays, means a bundle of light rays. See, there are so many light rays are coming from this source. From that light rays, I will choose certain number of light rays. This and this light ray and this light ray and this light ray. See, these are the different light rays. Always the light rays must be given an arrow. This arrow indicates what? The direction in which they are actually traveling. They are coming downwards from the source of light. There are still some other light rays are also there, but we are not going to deal about them. Just we are discussing about how to understand a beam of light. Okay. Here you can see this bundle of light rays. Here 1, 2, 3, 4, 5, 6. Some 6 light rays are here. We can see, but so many number of light rays will be there. So these all light rays, they all together as a bundle is known as a beam. This is a beam of light ray. Beam of light ray. Understand? This is a beam of light ray. Beam of light ray in the sense a bunch of many number of light rays which are all traveling together. All traveling together is known as a beam of light ray. So, how many different beams of light rays are available? There are 3 different beams of light we deal in the physics. Okay. What are the 3 different beams of light? Let's see now. Here in this example, if you take, this is a source of light. Let us take the source of light like a point. This maybe it is the sun, maybe it is a tube light, or maybe it is a candle, whatever that may be, which gives the light is known as a source of light. So from the source of light, light spreads in all the directions. So I will take the light which is coming in one direction like this. So see, here some of the light rays are coming in this way. Still there are so many light rays. Okay, they're also going in this direction and all the directions in the three-dimensional space. But I will take this beam of light ray. In this beam, it means in this bundle of light ray, what we can see, all the light rays are originating, means they are producing from a single point, from a point. This point is called what? Source of light. Okay, and from that particular point, they are spreading in all the directions. They are going to different directions. This is coming this side and this is going on another direction. This is coming vertically downward and they are going in different directions. But all of them have been produced at a single point. This type of beam of light ray, in which all the light rays originate, means they generate at a particular point and they spread in all different directions, is known as diverging beam. This beam of light is called diverging beam of light. Diverging beam of light. And this property is also called divergence. Divergence. Understand? Divergence means what? Starts at a particular point and all of them travel in different directions. They spread in all different directions. That is called divergence. And that particular beam of light is called a diverging beam of light. Okay. Next, opposite to it. It means they are coming from all different directions. Another beam of light. Here all of them are coming from different directions, like this. And another light ray. See what happens here? The light rays are coming from different directions, but all of them are meeting at a particular point. It means all of them are focused at a particular point only, isn't it? It means all are coming from various directions and finally they are meeting at a common point, at a single point. This type of light ray, the beam of light ray, is known as converging beam of light ray. This is called converging beam of light. Here all the different light rays are coming from various directions and finally they are meeting at a particular point, meeting at a single point or focusing. You can also call focusing. They all are focused to a particular point, as to a single point. This type of beam is called converging beam of light. Here all the light rays in this beam of light ray all are coming from different directions and they are finally meeting to a particular point. So this type of beam is called a converging beam of light. Okay, and this property is also called convergence. Convergence. Okay, now convergence means what? Coming from different directions and meeting to a particular point. This is called what? And meeting at a single place, single point. That is called what? Convergence. Okay. Next, another type of light rays, another type of beam. That beam is called parallel beam of light. It is another type of beam that is called a parallel beam of light. First one, this is the diverging beam of light. Second one, converging beam of light. And the third one is a parallel beam of light. Parallel beam of light. So really there will be no any beam of light parallel actually. But if you take a converging beam of light or a diverging beam of light, a little part of that beam becomes, or it looks like a parallel beam of light. Here you can see that actually from the sun or from the source of light, the light ray starts in the form of a diverging beam of light. Okay, now all the light rays are diverging only. They are diverging only. But after traveling a long distance, so long distance comparing to the size of the source, okay, you can take some more light rays. Yes, after traveling longer distances, what happens? The light rays, they become parallel to each other. It means if you take a small part of this beam of light, I will choose this part, this part. In this part, if you observe only this portion in the square size, if I observe the light rays, see all these light rays are nearly parallel to each other, isn't it? So in this way, this portion of beam of light is called parallel beam of light. Really the parallel beam of light is not there. Okay, we can produce the parallel beam of light in another ways also. We will discuss in this chapter or in the next chapter about how to produce the parallel beam of light by using the convex mirrors or concave mirrors or convex mirrors, or even by using the lens we can produce the parallel beam of light. But we can understand the parallel beam of light means the beam of light in which all different light rays are parallel to each other. Means all of them are parallel to each other. This type of beam of light is called a parallel beam of light. This is called a parallel beam of light. So this is the discussion about different types of beams of light. Okay students, once again I will explain you. Beam of light. Beam of light mean a bunch of different light rays which are combined or which are traveling all together in the form of a bundle. Okay, that bundle of light rays is called the beam of light rays. These are three types of beams. One is the diverging beam of light, and another one is the converging beam of light, and the last one is the parallel beam of light. In the diverging beam of light, we can see that all the light rays they produced from a single point or from single source of light. This point is nothing but a source of light, and from there all of them are moving in different directions. They are diverging. Diverging means what? Move, starts from a point and move in different directions is called divergence. That is called the divergence, and this particular beam of light is called diverging beam of light. And next is the converging beam of light. Here in this converging beam of light, we can see that all the light rays are coming from different directions, and all of them are meeting at the same point. It means this property is called convergence. Coming from different directions and meeting at a particular point is called convergence, and this particular beam of light is called converging beam of light. And next, the parallel beam of light. In this parallel beam of light, all the light rays are parallel to each other. So this is called the parallel beam of light. Okay, this is a little discussion about different types of beams of light. So this is the end of this topic. We shall meet in the next video with more discussion about the spherical mirrors, how the real spherical mirrors are there and how do they produce the images. Okay, so until then, take care. Bye bye.